These two equations are similar to part of question 7. Now, part A says you're to integrate 5x cubed plus 7x squared minus 2x minus 7 with respect to x. Let me put it in bracket so that it shows that everything applies to the integral. So here, for part A, remember now, when you integrate x cubed or any power of x, you have 5x cubed here. You're going to add 1 to the old power to get the new power, and you divide by the new power. Alright? Plus 7x squared. You add 1 to the old power to get the new power, and divide by the new power. Plus 2x. 2x means 2x to the 1. You add 1 to the old power to get the new power, and divide by the new power. Plus 7. 7 means 7x to the power of 0. You add 1 to the old power to get the new power, and divide by the new power. So then, what you have now is 5x to the 4th divided by 4 plus 7x cubed over 3 plus 2x squared. Oh, I had said 1 plus 2 here. It should be 1 plus 1, not 1 plus 2. Alright, x squared over 2 plus 7x divided by 1. So, another way you could write it is 5 over 4x to the 4th plus 7/3 x cubed plus 2 cancels 2, so it's just x squared plus 7x. 7x divided by 1 is just 7x. So that's the integral. Alright? Let's look at question 2. The integral of x cubed, or part B I should say, is the integral of x cubed e to the x to the 4th dx. E to the x to the 4th dx. Alright. So, here, you use integration by substitution. Because you have, let me rewrite e to the 4th here. It should be e to the x to the 4th, right? Here, you have e raised to something. E raised to a function, but this now, x to the 4th, is another function. It's a function within a function. And it's multiplied by another function. So, let's see if we can use substitution. Let u be equal to x to the 4th. Alright? Because that's a function within the other function. Hopefully, we can differentiate u and have it cancel out the x cubed. But let's see what happens here. If u is x to the 4th, then when we differentiate u with respect to x, the u by dx would be 4x cubed. Alright. Now, if we consider multiplying both sides by dx, we get du is equal to 4x cubed dx. And let us now make dx the subject by dividing both sides by 4x cubed. What you would get is du over 4x cubed equals dx. Let's switch it around and say dx is equal to du over 4x cubed. Alright, this is dx. Now that we know that this is dx and this is dx, what we could do is this. We have integral of x cubed e to the x to the fourth. The integral of x cubed e to the x to the fourth dx is the same thing as the integral of x cubed e to the u, because u is x to the fourth. We could wait a little bit before we change it anyway. Let's just put it back as it is, e to the x to the fourth dx. But dx is du over 4x cubed. So it seems as if we should now integrate with respect to u. Now remember that u is x to the fourth. So we could rewrite this as the integral of x cubed e to the u du over 4x cubed. Now this is the same thing as the integral of x cubed, then we have e to the u du, and then we had 4x cubed under here, so you could have it under the x cubed, so it's 4x cubed. Now what do we have here now? This is equal to x cubed will cancel x cubed. You can see that. So it's the integral of a quarter e to the u du, which you could write as a quarter integral of e to the u du. Now, you remember that the integral of e to the x is e to the x plus c, right? Now, in the same way, the integral of e to the u du, integral of e to the u with respect to u, is going to be e to the u plus c. Alright? But what was u again? U was x to the power of 4. So therefore, what we have is that this is equal to a quarter e to the x to the fourth plus c. Oh, by the way, remember this part didn't add the plus c. Should add the plus c up here, just remember. So e to the u plus c is the answer for this one.